Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. एथरे मु ऑलरेडी प्लस 2 सेकंड ईयर सिलेबस कंप्लीट कर सारछि एबे मु प्लस 3 CBCS ऑनलाइन क्लासेस रो वीडियोज गुडा अपलोड करिवि जदि भल लागिला ताले लाइक कर देबो एवं सब्सक्राइब कर देबो जो वीडियोज गुडा मु अपलोड करिवि तार नोटिफिकेशन पई एठी बेल आइकन को ऑल रे सेट कर देबो गोटे इंपोर्टेंट जिंस वीडियोज रो ऊपर एठी जो 3 डॉट्स देखुछो तार क्वालिटी एठी देखो बाय डिफॉल्ट 360 अछि तमे ताकू पढे मध्ये परिबो एठी एडवांस रे क्लिक करी तमे रिजोल्यूशन बढ़े परिबो प्रति वीडियोज रे मु पीडीएफ लिंक देबी ताकू एठी ड्रॉप डाउन लिस्ट रो तमे क्लिक करी डाउनलोड मध्ये करि परिबो पीडीएफ को लास्ट रे एठी जो मोर चैनल नेम अछि याकू क्लिक करी तमे एठी प्ले लिस्ट को जाई मु प्रति वीडियोज को यूनिट वाइज एज पर सिलेबस सजाई की रखिथिबी तमे सर्च करि परिबो ओके थैंक यू
हेलो स्टूडेंट्स आज रो टॉपिक रे हमें चेंज ऑफ टेम्परेचर ड्यूरिंग एडियाबेटिक प्रोसेस विषय रे पढ़िबा देखो एडियाबेटिक प्रोसेस माने आमे जानिछु हियर द हीट Q remains constant and hence the entropy S will also remain constant but the volume V changes. Now to study the effect of temperature on adiabatic expansion we should study the changes in temperature corresponding to the changes in volume at constant value of this entropy, or in other words we should determine the value of del T by del V at constant entropy. So एथिपाई आमे Maxwell's first thermodynamic relation यूज करिबा del T by del V at constant entropy यार वैल्यू आछि minus del P by del S at constant volume. Okay, so एठी देखो सेकेंड लॉ ऑफ थर्मोडायनामिक्स रो आमे जानुछु जे del S is equal to del Q by T, so that del T by del V जो ऊपर हमें वैल्यूटा पाइला याकू एबे आमे टिके सजाई कि जदि लेखिबा ए जो del S रो वैल्यूटा को रिप्लेस कर दबा ओके सो इट इज माइनस del P into T by del Q और माइनस T into del P by del Q at constant volume ओके सो एबे क्रॉस मल्टीप्लिकेशन हिसाब रे जदि एठी del T आमे तळे ऊपर मल्टीप्लाई कर देला ताले it will be minus T into del P by del T at constant volume into del T by del Q at constant volume. Okay, एठी cross multiplication use करछु आमे. Now the coefficient of increase of pressure with increase in temperature at constant volume which is denoted by beta याको आमे define करिबा like this beta equal to change in pressure divided by original pressure into the rise in temperature at constant volume, that is beta equal to del P by P del T at constant volume or 1 by P into del P by del T at constant volume, or del P by del T at constant volume is equal to beta P. Also from the definition of specific heat at constant volume CV आमे जानिछु del Q by del T at constant volume is your specific heat CV. Okay, एबे जदि आमे फर्स्ट लॉ ऑफ थर्मोडायनामिक्स यूज करिबा ताले आमे जानिछु dq is equal to du plus pdv हुए. Okay, at constant volume this dv is equal to 0, so that del q is equal to del u hela. एबे both side रे dt divide कर दबा. Okay, and taking constant volume, right, so that this is in terms of partial derivative this value is your specific heat at constant volume यार value टा हुए. Okay, so CV रो value आमे पाइला केते ना del u by del t at constant volume. Okay, पुणी del t by del q at constant volume जदि आमे बाहर करिबा एठी del q को आमे रिप्लेस करिबा del u जगह रे. Okay, so del t by del u hela ei relation ru देखो this is nothing but the reciprocal of your specific heat at constant volume. Okay, so याकू एबे substitute करिबा along with the value of del P by del T जोटा हमें पाइथिला या पूर्वरु. Okay, so substituting the value of del P by del T and del T by del Q at constant volume in the equation 4.5 माने this equation. Okay, এই দুইটা value हमें replace करिबा. Okay, ताले after replacement equation 4.5 we will have del T by del V at constant entropy will be equal to minus T into beta P by CV. Okay, now जदि आमे कहिबा delta V होची small increase in volume then the corresponding change in temperature due to the adiabatic expansion, suppose it hela delta T, the change in temperature, then it is given by delta T by delta V, which is equal to, from this equation, minus T beta P by CV, or delta T ର value ଆମେ ପାଇଲା minus T P beta by CV into delta V. Okay, now the value of this beta is actually positive for substances which expand on heating. Okay, beta hochi ame jemti kahithila, this is the coefficient of increase of pressure with increase in temperature at constant volume. So यार value ta positive रहिबो for substances which expand on heating, because the pressure always increases with the increase in temperature. Now during the adiabatic expansion, delta V is also positive because expansion hochi, so this delta T will be negative. Okay, and it means that the substances show a cooling effect. देखो delta T यदि negative माने कमी जाउची, right? So that cooling effect हमें देखिया को पाउचु when it is allowed to expand adiabatically. Now for those substances which are having negative value of beta, that is beta less than 0, then this delta T will be positive and greater than 0. So it means that these substances will show a heating effect when they are allowed to expand adiabatically. Okay, so rubber is an example of substances having negative value of beta. Okay, so it a heating effect देखेता है ये जो rubber, right? Now for isothermal expansion, isothermal माने एठी temperature will remain constant, then the amount of heat for a substance having positive value of beta is given by delta Q, which is equal to mCV delta T, or याकू यदि replace करिबा हमें, then minus m Tp beta into delta V. Okay, so this amount of heat should be supplied to the system in case of your isothermal expansion. Okay, now let us see what is adiabatic compression. Adiabatic expansion हमें देखिला, एबे adiabatic compression देखिबा. देखो in case of adiabatic compression we have to find the change in temperature when the pressure is increased. So एथिपाई आमे fourth Maxwell's thermodynamic relation को use करिबा, according to which del T by del P at constant entropy is equal to del V by del S at constant pressure. Now we go for the cross multiplication, del T एठी तळे उपरे multiply करिबा, so that we are getting del V by del T at constant pressure into del T by del S at constant pressure. Okay, so एठी एबे del S रो value को आमे replace कर देबा जेमति आमे पूर्वरु करथिला del Q by T, so that it will be like this. Okay, now we consider unit mole or 1 mole of a substance, then the specific heat at constant pressure Cp is given by del Q by del T at constant pressure. Okay, because del Q is equal to mCp del T, okay, for m number of moles. Then by definition of coefficient of increase of volume alpha at constant pressure, it is defined as alpha equal to increase in volume divided by original volume into the rise in temperature, that is 1 by V into del V by del T at constant pressure. Okay, so from this del V by del T ର value ଆମେ ପାଇଲା alpha V, and del T by del Q ए इक्वेशन रो आमे पाउछु 1 by Cp. so ए दुई वैल्यू को इक्वेशन 4.7 जो ऊपर आमे पाइथिला, दिस वन, ए इक्वेशन ए दुईटा वैल्यू आमे पाई गला. सो ए दुई वैल्यू को आमे जदी पुट करिबा, देन इक्वेशन 4.7 will be reduced to this one, del T by del P at constant entropy is equal to alpha Vt by Cp. Okay, so above relation can be expressed in terms of small change in temperature delta T due to corresponding small change in pressure, that is delta P, during the adiabatic compression. Okay, it will be expressed like this: delta T by delta P, from this equation it is equal to alpha Vt by Cp, or delta T रो value हमें पाइला T alpha V by Cp into delta P. Okay, so it clearly indicates that if alpha is positive, then the adiabatic increase in pressure will cause the temperature to rise. Okay, so this is all about the change of temperature during your adiabatic process.
Thank you.